Hi there, this is Mr. Bainey. The lesson we're going to look at right now is 9.3 Properties of Rotations. The standard that we're going to look at is 8.G.1c, and the essential question: how do you describe the properties of rotations and their effect on the congruence and orientation of figures? So some vocab for this lesson is that a rotation is a transformation that turns a figure around a given point called the center of rotation. So the key word here is that rotation means that it's turning. The center of rotation, think of like the sun is the center of our solar system, and we're going to be turning around that center. Okay, the center is like what stays still, stationary, and everything else moves around it. So what's going to be important here is that you understand which way is clockwise. Okay, again, think like a clock. And which way is counterclockwise. Because this is going to describe which way we are rotating. And then also think about if we were to go around in a full circle, that is 360 degrees. If we're only going to go halfway, oops, that's not halfway, that's all the way around again. If I were to only go halfway, like so, that represents 180 degrees. Right, and in between those is going to be a 90-degree turn and then a 270-degree turn. So those are the numbers to know when we're dealing with rotations. So the first thing I want to show you is a visual of what a rotation will look like. And again, if I rotate a figure, you want to think about, is the shape still congruent? Right? Is the image still congruent? And is the orientation the same, or is it different? So let's look at the graph that's right here. Same thing as with 9.2 if you watch that video. These two explore activities are really good to try out on your own or with somebody. Even with me if you want to come in and explore it with me in my classroom. But it's a little difficult for me to do it on the video. So instead, I'm going to draw this shape and show how it looks being rotated. So here is triangle ABC. Trying to trace it as best I can here. And then let's rotate it. Okay, so the center of rotation is going to always be the origin. And remember, the origin is the point 0, 0. It's where the x-axis and the y-axis meet. So take a look at this. If I rotate it counterclockwise, right? Counterclockwise means that it's going to look like this. Okay, so that right there represents 90 degrees counterclockwise. Okay, this represents 180 degrees counterclockwise from where I started. And then this is 270. And then when I go all the way back around again, it's 360. And then we could always do in between. As you notice, it continuously turns. It doesn't just skip, right? So I could let this go, and you'll see it'll just keep going. So this is the counterclockwise motion. And on the other hand, I could go the other way, right? So if I started here, I could stop at, this is 90 degrees clockwise, 180 degrees clockwise, 270 degrees clockwise. So every time I'm rotating these, you want to think of, is my new figure, my red triangle, right, compared to my blue one, is it the same shape? That's a yes. Is it the same size? That's definitely a yes. Is it the same orientation? So are the shapes still facing the same way? And that answer is no, it's not. So point A actually ends up being the same as A prime, since it's both at the origin, right? Remember I said that the center of rotation never moves. Point B prime is going to be right here, and point C prime is here. So where I stopped at is the rotation, right? If I did in fact go this way, I turned, I guess you can think of it as 3 times all the way around. This is a 270-degree rotation counterclockwise. So I put CCW for counterclockwise. It's also the same as if you went 90 degrees clockwise, right? If you went the other way, then you only need to move once, or one 90-degree turn. Okay. I'm going to show you another visualization of it happening on the next page. On the Explorer, I'm not going to do the Explorer, but I do want to show you the visual again. Okay, on this next page, so let's take a look at this, this trapezoid looks like. I'm going to, again, trace it as best I can. Then let's go ahead and rotate it. So my center of rotation is the origin. So this is going to look a little bit different than the previous one, because the previous one had, it had these, one of the points of the triangle was actually on the origin, but this one doesn't. So let's see what it looks like. If I were to rotate it counterclockwise, it's going to look like this. So check that out. This is a 90-degree counterclockwise turn. There's 180. Okay, there's 270. All the way back to 360. So you see it's staying the same shape, but it is changing orientation. But it is congruent, right? Same shape, same size whenever I rotate it. Okay? Same thing as if I go this way. This is clockwise. So let's stop when I go 180 degrees. Let's stop. Oops. No, I didn't want to do that. Let's go there. So not perfect, right? Because my tracing is not perfect here, but everything pretty much turned upside down. And so sometimes it's hard to visualize this. I do have a way you can do this using a transparency and putting it on top of your paper. So come in and see me if you would like a transparency. But I have point P prime is right there. A prime is here. Okay. R, one thing that you can notice here is that R and R prime are the closest to the origin, right? So if they're spinning around the center of rotation, their distance to the origin should remain the same. And then finally, T prime is going to be right here. Okay, so let's take a look at the your turn near the end of the lesson. And number 6, 7, and 8. So we're going to graph the image of quadrilateral ABCD after each rotation. And we have 180 degrees. And I guess it doesn't matter which way, right? 180 degrees, think about it. If you went clockwise as opposed to counterclockwise, you end up with the same thing. 270 degrees clockwise. And then part A says find the coordinates of point C after a 90-degree counterclockwise rotation, followed by 180-degree rotation. So I do want to show you these visually, because I think this is one of the hardest to just mentally picture it. It's a little bit difficult. So let's trace this first. Then, you know, let me try that one more time. Let's trace it. Okay, that's a little better. Then let's set rotation on this, and then let's rotate. So the first thing I want to do is a 180-degree turn. So let's rotate this 180 degrees. I'll end up right there. So that is the 180-degree rotation. Let's actually go back, and then I think what I'm going to do is, let's copy this. You know what, I'm going to copy this one a few times just so I can reuse it again. So my first one is 180 degree rotation. So it looks something like that. Okay. Number 7 is 270 degrees clockwise. So here is my image here, and 270 degrees clockwise is going to be going, oh, and I don't want this one to be moving. So let's stop this one from moving. Then let's rotate number 7, 270 degrees clockwise. So it's going to look like this. If I go clockwise, it's going to go this way, right? Going clockwise. 270 degrees is almost all the way around, and it's going to look something like this. Okay, not perfect, but you can see the points that it's closest to, and then work with it from there. So it's going to look something like that. And then lastly, I have the same quadrilateral, right, starting at that A, B, C, D. And then I want to find the point C. So I'm going to add to this. Point C is this one right here. I want to figure out where that's going to go if I go 90 degrees counterclockwise and then 180. So let's set this on a rotation. Then I'm going to go 90 degrees counterclockwise, right? That's this way. And I get this. Then 180 degrees from there. So that means I'm going to go halfway around, which actually brings me here. Oops. Right there. So point C is actually pointing to the bottom. So I can call that my point C, I don't know, triple prime, right? This is the third one that I did. So C triple prime. And if I wanted to label those other ones, I could. You probably want to get in the habit of it. Point A is always going to be there on the origin. So point D prime, the very first one I did 180 degrees, D prime is here, C prime is here, and B prime is here. Right, everything kind of turns upside down, sort of. And then when I did my 270 degrees clockwise, C, we call this C double prime for my second image. I have D double prime will be here. That's off a little bit, but that's okay. And then I'm going to have, I'm trying to figure out if this is actually correct. This looks like it's off a little bit, I think. But B double prime will go here at the bottom. Okay, so it is off a little bit. This one should actually be moved up quite a bit. So it is off a little bit, but we will leave it at that. Okay, so this one, it's a little bit difficult for me to move these nicely. So that's probably a little bit more accurate now because I know that B double prime should not be on the x-axis. So now it looks a little bit better. So, but it looks kind of like that, kind of like a pinwheel almost when I put all those on there. Okay, and that is the end of this lesson. If you happen to still be watching this and you stuck with me till the end, come in and see me and I'll give you some PBIS points. Mention mention the word turn, and then I'll give it to the first 5 people. So the word turn, I'll give you some PBIS points. Thank you so much for watching. Have a great day.